Thanks for inviting me on this. So it's as you said, I'm representing Vodafone. I lead the IoT security function. A challenging job, you know. When you say that at parties, people say, "Yeah, yeah, that's interesting." And I think we're all of us here are sort of in that kind of same role. What I'm going to try and do today, though, is to try and give you some insights into 5G, the security models that are being created around that, and I think there's some lessons learned there that could be applied to other areas of IoT as well. But also, I think it's we're approaching an inflection point in the way that telecommunication works generally, and I think there's some very interesting things ahead for the next few years. I'm not going to be selling anything. This is going to be agnostic of any particular company, but I am passionately believe that communications is actually a force for good, and we face some really difficult societal challenges at the moment with climate change and global warming and COVID and everything else. And I see communications as one of the tools that is really important for society to get right and to use to everybody's advantage. So I do kind of passionately believe in that. So I'm not selling anything, but I will sell that. Okay, I've got a deck. It's quite a full deck. So my presentation is split into two parts. So the first 10 minutes or so, I'll talk about 5G generally, try and get underneath the hype and what's the real story there. And then the final 2/3 will be talking about security around 5G and the mechanisms, etc., that have been evolving around that. So what is 5G? Well, basically, it's the strategy for the next sort of 15 years. It's actually a series of releases. We're actually rolling out release 16 at the moment. It's actually, I mean, the releases are tied to dates, annual dates, and originally when it started, it was meant to be every year there'd be a release, but that's kind of drifted somewhat. So we're in release 16 now, and it's actually 2021. The release is now about 18 months apart, and there's going to be many more releases. So there's 4 more releases planned over the next 5 years or so, and then we've got the advent of 6G, which is even better. So it's an evolving standard, but I think it's very interesting the way it's evolving, and the acceleration in which things are changing at the moment is actually really it's a bit of a roller coaster. So the way it works is the ITU, the International Telecommunication Union, specifies the vision and the requirements. That's fed over to the 3GPP organization, and they define the technical specifications. It's then approved by the ITU, and then the manufacturers and the vendors and the telco players can actually start, making and using the equipment. So that's the kind of the process. There's a quote here: "The cloudification of communication services is likely the most consequential decision you will face this century." Now, I say that, use that quote with some tongue in cheek. It comes from a company called Metaswitch, which was a takeover. It was bought by Microsoft quite recently. They actually provide cloud services into the telco industry. So smart acquisition by Microsoft, and you kind of understand why they might make that quote. But I think there's some truth in it. That's why I put it there, because there is some truth in the fact that the massive cloudification we're seeing in terms of IT systems and telecommunication systems generally are going to be highly consequential. And I want to talk about those things. And I think people who are familiar with cloud will understand that cloud also has some security challenges as well. So talking about how those challenges will be met. This is what the feature improvements we're going to see with 5G over 4G, and it's kind of a spider diagram which shows you that effectively 5G makes better use of spectrum. And there's a number of different parameters described here. Some people say it'll be 1,000 times more efficient in use of spectrum. Some people say 10, but effectively what we're looking at is almost an order of magnitude in terms of improvement, in terms of the efficiency in which we use spectrum. And if you think of spectrum as actually being an asset, a resource that we have, any business what they'll try and do is sweat that asset, sweat that resource to get the maximum value for it. And I think the nice thing about spectrum is, if you think of it as being a human asset that we can use, how best can we use that asset to further the needs of society? And the simple thing is, I mean, what's happened is that Ofcom has been selling off this spectrum to the telco providers. It's generated 2 billion in revenue for the Treasury in the UK this year. So there is some, the immediate benefit is that this is taxed, and the telecommunication industry pays for it. But it's actually how you use that spectrum, how you use that resource to get the maximum value. So what's been done so far is there's really three areas of spectrum that are involved. One is the low frequency, which is 700 megahertz band. That was, again, spectrum was sold off in spring this year. That's really designed for sort of rural and areas where you want to have a large coverage over a broad area. The beauty of low frequency spectrum is that when you think of it, in terms of music, if your next door neighbor is playing reggae music, you'll hear the low basses coming through, the low frequencies travel through the walls. The same applies for radio spectrum. The low frequencies will travel further and won't be disrupted by trees or leaves in the rain. As you move up the spectrum, you'll find that they will be the data carrying capabilities become greater. There's more fidelity in terms of the information that it can contain, but at the same time, it is more susceptible to obstacles. So obstacles like, as I said, if you have a tree and it's in the wintertime, your 2.4 gigahertz spectrum will go through that in the wintertime. As soon as you get leaves on it in the spring and it rains, your link will start working. So this is sort of the basic physics of the way spectrum works. So low frequency has been auctioned off. Mid frequencies have been auctioned off. And mid frequencies, you see the announcements that are in the press regarding 5G. It's mainly the mid frequencies that are actually being used at the moment and exploited to offer these 5G services. Then we've got the high frequency, millimeter wave, it's called, over 26 gigahertz and going up to 100 gigahertz, which have got massive data carrying capability, but they have very limited range. People talk about hundreds of meters. I've deployed systems myself, separate in another incarnation, over a couple of miles with point-to-point links, but effectively these very high frequencies, these millimeter wave frequencies, got the ability to carry huge amounts of data. The other nice thing about high frequencies is the actual antenna sizes. So to get an optimum antenna size, it's to do with the wavelength. You have multiples of the wavelength, and with 2.4 gig in the mid, it's actually 12 centimeters long, about that long. That's the wavelength of the radio emissions from your microwave oven and also on your Wi-Fi router. When you go to the millimeter wave, then the wavelengths become tiny, much smaller, and you can actually construct antennas which are much smaller as well, because the way the antennas work is it's basically the receiving elements basically it's they need to be at least the length of the wavelength of the receiving waves. So you can build antennas which are much smaller. And what's happening in the millimeter wave area is people are designing these MIMO antennas, which have got many antenna elements, and that introduces another mechanism which allows you to do things called beam steering. And with these MIMO antennas, you can actually use the same chunk of frequency to give sort of the active beamed signals into locations you want it to be. So this diagram shows the difference between 4G and 5G. You can effectively use the capacity for much more connectivity. So the applications, I'm not sure if I'm getting lots of stuff on my screen about breakups and stuff. Not sure if you can all see that, hope not. So basically 5G is being pitched into three different areas. The first one is the massive broadband and deployment, which is really about what the consumers get. Now, you'll have seen in the press, there's really, 5G has not really been a spectacular public success. People are a bit bored. Okay, we got 5G. What does that mean? It means our our connections work maybe 2 or 3 times faster, more available. But to the consumer, it's really that's really it is what it is. It's faster, better, more available. It's only when you start getting to the other corners of this particular triangle that it starts to become really interesting. And that rollout hasn't really started yet. When we're talking about ultra high reliability and low latency communications, this is for things like autonomous self-driving cars, where the Volkswagen that you're in is able to talk to the BMW car in front of you to know when the person in the car in front of you is braking. That sort of very, very, very low latency communication is critical in sort of high speed scenarios where you're driving a car, but also it's important in factories and automation and power distribution and power production environments where you've got systems which are very, very dynamic, changing very, very quickly, and you need to be able to respond and react very fast. So those kinds of applications are going to be opened up by 5G. And the other area where there's other corner of this triangle is massive IoT connectivity, where we're talking about billions of devices rather than hundreds of millions. So it's those are really the 3 areas where 5G is currently being pitched at, with particular applications in different sectors. So there's 2 flavors of 5G, non-standalone and standalone. What you're seeing in the shops at the moment in terms of being rolled out is non-standalone, and effectively what they've done is, in the early stages of the standards, they define the standards for the phone manufacturers. So most Android phones, mid-range and high end, will do support 5G. My iPhone, I got an iPhone here, it's iPhone 11, it doesn't. So you're going to have an iPhone 12 or iPhone 13 if you want to have 5G, but it's being built in increasingly into the sort of telephony appliances. And effectively what we're seeing here on this little diagram on the left is that it's mainly bolted on top of 4G. So they've used a 4G infrastructure, and effectively what they're doing is they're taking advantage of this additional spectrum to give you faster, better, more, etc. Standalone, which is being rolled out as I speak, it's release 16, the standalone feature started to become available. It's being rolled out now, and that's where you've got a completely separate core to the 4G, and you can actually start taking advantage of the more exciting features of it. But at the moment, what we're seeing is more bandwidth, better coverage, increased speeds, and that's kind of it. It's only tomorrow and the year after that you'll start seeing the really interesting applications for IoT and massive rollouts, and also the real-time stuff. So these are kind of the markets that are being attacked with this. Now, it's interesting, if you look at the this is Huawei's vision from 2013, this slide, you can see the sort of the sectoral areas where 5G is being expected to be important: autonomous cars, connected cars, telehealth, remote control of factory automation, and wide area monitoring. These 4 different areas. The actual features that are going to be delivered by 5G, there's different linkages here between each. And for some of these areas, you'll see a lot of new requirements coming in. Connected car is what I think was what we're going to see first, but I don't know. These applications are all interesting and all exciting, but this is tomorrow stuff. It's not stuff that's really available yet, but it is expected to be available in the next short time frame. Now I'm going to talk about 5G security. The previous talks were talking about the actual background to it, but essentially what we're looking at is better use of the spectrum, better ways of using it, faster connections, so you've got much more ability to react immediately to real-time events, and that entire ecosystem, that entire set of componentry is going to be deployed using a highly cloud model. It's a complete cloudification. All of those components will be delivered as cloud solutions. So a lot of the 5G IoT security features are actually focused on cloud initiatives. But what you've got to understand here is that by cloudifying the telco stack, what that means is you've now got an ability to accelerate the release of different versions and accelerate the delivery, accelerate the way that new features are introduced, new security controls are introduced. It's all software as a service, and it is actually transformative. I was working on designs for telco systems, a few years ago, and it was all big, expensive boxes, and you had to plumb them all together with wires, and it used to take years to actually do a rollout of a new service for a national telco. Years, literally. But now it's cloudified. Everything is an API, and you can actually specify what you want as an API. It means you can deploy these systems very, very quickly. You can upgrade them very, very quickly. You can do software patches in an automated fashion. You can do all of this stuff, and it's frictionless, providing you get it right, providing you've got your security controls in place, you've got all your architecture done right, and providing all of the componentry is done in the right way. So a lot of the efforts in the 5G security area are focused on making sure that industry does it in the right way, and I want to talk about those right ways now. So what I'm going to do is I'm going to start from the bottom up, talk about devices, and then work up the stack, ending up talking about regulation and legislation. So we've heard a number of speakers already talking about good old ETSI, EN 303-645, the security good practices. That's all well and good. It's currently a standard, expected to be legislated and incorporated into law fairly soon. When, I don't know, but all good stuff. There are a number of industry initiatives around cloud ecosystems. We got the AWS, they've got the IoT Core and Greengrass, and FreeRTOS, they got their version of FreeRTOS that is provided for device developers, and you can do amazing stuff with it. I've got a board here. I did have a board here. Yeah, I've got a board here. It's a little thing I'm playing around with. I'm a diver by my hobby, and I've got a little ESP32 and a bunch of sensors, and you can knock these things up with FreeRTOS, integrate them to the Amazon environment really, really quickly, really easily. And then the CPUs here cost €2. That's units of one, €2. They come with lot of security functionality. The previous talk in terms of hardware security, it's got true random number generator, got cipher suites, it's got accelerators, it's got isolations, the encryption of memory, off-board memory, etc. It's got a lot of really capable stuff, and it's kind of got these wrappers here provided by Amazon in terms of IoT Core and Greengrass, which allow you to create mechanisms to do things like software updates, authentication, identity management. All of those things are built into these ecosystems that the cloud vendors are providing. And FreeRTOS, like nice little multitasking executive, again, it's allowing you to create devices much quicker, much easier, with kind of the componentry for the security functions kind of available and built in. It's becoming easier, and that's the key, I think, to making 303-645 realizable. You have to make security easy. At the moment, well, previously it used to be very difficult. You've got to encrypt everything. You've got to use the right crypto suite. You've got to do your root of trust. You've got to make that very secure. Really hard to do if you're starting. If you're trying to build maybe some application for some particular use case, and it's expensive to do. But so this is what I'm saying here is the cloud ecosystem is actually providing a lot of these tools that will make it easier to do this. Microsoft got a slightly different strategy. They have procured a number of telco equipment providers, Affirmed and Metaswitch. These are cloud companies that develop cloud solutions in the telco space, and clearly Microsoft is seeing themselves as becoming almost telco in terms of the creation of these services. So they're very, very active in the 5G world in terms of the higher added value services they can create around their product set, and how they can incorporate that into the 5G environment. And what we're seeing with devices, price point, rapid reduction, as I said, €2 for that. You can expect devices to be sub €1 pretty soon. They will be very, very powerful. They'll have integrated capabilities, communications, modems, integrated SIMs, GPS capability, the security functions, and this is cheap. It's very, very cheap, very accessible to the market, very accessible to developers, lots of good IDEs around them. So what I'm seeing here is an opportunity for people to make devices in the millions or billions or trillions very, very cheaply, almost throwaway devices that you can use to instrument. I mean, there's one of the speakers at today's conference is they've got an IoT solution that is measuring the circumference of trees as trees grow as a way of actually monitoring carbon capture in the trees. So that kind of application becomes very, very easy and possible if you can get the price point right down to sub $1, sub €2. And that's what's going to happen. We're going to see devices which are massively cheap. But that then gives us the problem that we were talking about in the previous session, in terms of how you get the NIST compliances and the 303.645 stuff done. It's an interesting challenge, but that's what I'm seeing. I'm seeing opportunities to create billions and billions of IoT device solutions using this very low cost hardware, which is very, very capable. Now we move up to the protocol, 5G protocols. Now the 5G protocol is built upon 1G, 2G, 3G, 4G protocols. Now there's a diminishing return here. The 1G, 2G and 3G protocols, there was quite a lot of evolutionary work in terms of improving fundamental security issues in there. But since 3G is actually been, they're pretty secure, they're pretty reliable. There are some gaps. So the curve here is showing there's a diminishing amount of activity in terms of protocols. And I'm going to talk about 5 different areas where 5G is introducing some improvements, but these are kind of fairly marginal. So the first one, better radio interface security. So effectively what they've done is they've added integrity protection on one of the communication lines. For people who are not telco, what you need to understand here is that all the telco comms protocols use 2 communication pathways. One is the pathway that the voice is traveling along the user plane, the data goes across the user plane. The other pathway is called the control plane, which is used to set up the conversation and do all the background things. So you make a phone call, it calls the other person's ringer to ring or the engaged tone to come back. It controls the connection, and there's the user plane is the data. So what they've added here is integrity protection on user plane. It had privacy, it had confidentiality encryption protection before, but not integrity. Next one, IMSI catching. One of the things that people can do is they can put in a false base station and they can intercept the communication and identify the IMSI, the identifier on the telephony appliance that uniquely identifies your telephone. With telephones, there's 2 identifiers. There's the phone number that you have that maps to you, and there's the phone number. There's the number that maps to the SIM, and that's called the IMSI. So your phone number and your IMSI, when you register with an opco, with a telco, they map your phone number to the IMSI on the SIM that you're using. So that link gives you that's what happens when you move from one telephone provider to another. And there was a mechanism that allowed nefarious individuals to identify the IMSI used by a particular person as they went into a shop or went to it. And so this mechanism has now been put in place, so it actually can't be exploited. There's quite a lot of documentation on this on the web. There's a link here to the Electronic Frontiers Foundation, which explains how that works. There's one new area of protection. Next one, 256-bit encryption. This is all about quantum. This is Sundar Pichai, who is the CEO of Google, proudly sitting in front of his quantum stuff. And quantum computing is expected to, there's a high probability that it will make a lot of today's cryptography obsolete. So basically, modern crypto, certificate-based cryptography, is based upon difficult to solve problems. The thing about quantum is it creates mechanisms that allow you to solve those difficult to solve problems. So the expectation is that within about 10 years, quantum information processing will have mechanisms that can be used to attack the current certificate-based encryption mechanisms that are in place. Now, the key mechanisms built into a telephony system there's a hierarchy of keys, and at the very top you've got the KI value, which is provisioned onto a SIM at manufacturer time. It's a write once, read never value, and that is used to construct the keys beneath it. So it's the root of trust. We talked about in the previous talk about roots of trust. Well, the KI value is the root of trust in a telephony system on your phone. And all of these keys are planned to be moved from 128-bit, which they are now. In 5G, they'll be migrated up to 256-bit. The other thing about these keys is they're all using symmetric crypto. And the reason they're using symmetric crypto is because it is inherently resistant against quantum attack. So the advantage of symmetric over asymmetric cryptography is it is resistant to, basically you've got to search the entire key space. There's no shortcut. There's no difficult to solve problem to solve. It is simply a search space. So it's naturally resistant to attacks against it. So they will be moving all the keys in the key hierarchy to 256-bit. The standard for this is going to be closed in release 18, which is also going to be labeled 5G Advanced. That's the big thing, will be 5G Advanced. That's expected to happen mid 2023. So the standards committees are quite relaxed about this one because, as I said, it's already based upon a very crypto strong technology, which is quantum resistant. Flexible security policies. Now, this is quite cool. What it allows you to do is to create custom security policies to be applied to different services. So depending upon what sort of connectivity you're using and what sort of requirements you have and how it's all configured, it allows you to customize the security protection mechanism. So particularly things like the analytics that you run on it, or the filtering, or the web protection, or the firewalling. All of those things can be designed in and completely customizable on a use by use cases. So you may be concerned about denial of service attacks or web attacks, whatever. Then it allows you to put customizable security mechanisms into the ecosystem that allow you to do very fine-grained security protection on an application by application basis. So this was.
Sorry to interrupt, Tim.
Yeah.
Time is moving on. Will you be wrapping up soon?
Yes. Well, I'll zip on now. So I think the key thing. Sorry, I did start late for my own defense there, Jeff. There's a huge amount of regulatory work going on within the EU and national level. As I said, we had people from NIST earlier on today, but ENISA is working on a cybersecurity certification scheme. EU is working on a EU 5G toolbox, security toolbox, and then we've got all these standards committees working on security methodologies and common API frameworks, etc. What's happening here is there's an extreme amount of standardization going work about how the security ecosystem should work, how it should all be plugged together, how it should be assessed and managed, how it should run through its life, how it should be assured, and how non-compliances should be addressed. So here's an example from Nessus, the Network Equipment Security Assurance Scheme run by GSMA. And this shows you the process that you go through in terms of evaluating any particular component from any particular supplier. This is a response that came back. This is for a Huawei product, an eNode B node that they sell. It's published. It's in the public domain, so you can see the results. So what's happening is that there's a huge amount of this regulatory work going on behind the scenes. But at the end of the day, I mean, this slide was, I think, the most interesting one for me. And it came from the National University of Singapore. What they did was they looked at 5G and communications from the perspective of climate change. And they looked at how they could actually improve the way their campus operated to address climate change issues in terms of reducing waste, manage water resources more effectively, risk management, the atmosphere, etc. So for me, I think, as I said at the very beginning, I see 5G as an opportunity for the human race to use communications, make better use of its communications assets and resources in terms of spectrum. Oh, one thing I didn't mention, it will also converge all the other technologies. So 5G, broadband, fixed wire, satellite, all of these different delivery mechanisms for communications, it does integrate the lot. So effectively, you should be able to have a seamless communications experience at some time in the future.